Right, everybody excited to learn more math? Yeah, you giddy? Everybody's giddy. I'm okay with that. Let me just pull up the attendance sheet here to mark on some people. I love sneezing into a mask. It's great. It's the most comfortable thing in the world. Okay. Okay. Can everybody online hear me okay?
Yes.
Awesome. Okay. No weird stuttering issues or anything. All right. So for today, we're going to go back and do our usual level of some review. I know that one made me laugh too. So we reviewed some percentages that we did last time. Then we got plenty of different graphs and charts. I only have 1 or 2 examples for each one of them because there are, I think 8 different ones, many of which you're going to be familiar with already. So it's largely just reading and comprehension of those. You're not going to have to worry too much about them. But as long as you get the idea, because there was even one I wasn't particularly familiar with, so could be interesting. And if we once we pass that up, we have linear equations that we're going to start taking a look at. And if we have time, we have a lot more of it. I probably have the next 2 or 3 classes on this slideshow alone. So it'll be fun. It'll be fun. And yeah, anytime I try to plug in my charger without getting out of bed, I just, it's amazing how much effort you're willing to put into it when you know you could literally just take a step. Just one step, you're reaching and it's uncomfortable. And you it'd be quicker, but you just don't do it. All right. So reviewing percentages. This is just kind of a snippet of what we did last time. So again, remember that percent means parts per 100. So as it's phrased, percent. You know how many cents are in a dollar, so that's how many are in total percentages. So when we learned scientific notation along division with decimals, we learned that multiplying and dividing by powers of 10 can be done simply by just moving the decimal point over. Remember, if you divide by 10, you're just moving it over to be 1 smaller. If you multiply by 10, it's 1 digit bigger, etc. And since you're playing around with percentages, you're moving everything twice because you're playing with 100 instead of 10. So if you convert to decimal, like I have there on the second break there, converting 25% to decimal, 25%, you could just drop the percentage symbol and move the decimal point twice to the left. So instead of 25, you have 0.25. And that's all you really got to do for converting them to decimals. It's not bad. And then converting them back to percentages, you can move the decimal point twice to the right, and undoing what you just did. So it's not too bad. So you 0.63 can turn into a 63, so it's 63%. And it works exactly the same if you have more digits. So if I had, say, 0.255, that would be 25.5%. So it moves over twice, even if you end up with a decimal on your percentage, that's fine if you have a bunch of digits. So it works out pretty well. And then the weird one was to and from fractions. That one you don't see quite as often, but it does happen, and it's nice to be able to understand. So again, say if you looked at the 25% and you wanted to consider that as a fraction, anytime you're converting from a percentage to a fraction, you just have to put it over 100 and reduce. So 25 over 100, at 25 over 100, you can look at it and say, well, that reduces. 25 goes into the top once, 25 goes into the top, or into the bottom 4 times, so you get 1/4. Not too bad. And it actually works for any percentage. Like I put as an example here, 55 over 100. You would look at that and say, I can't really see a whole lot that would go in there, but 5 will go in there. So you give it a shot. 5 goes into the top 11 times. 5 goes into the bottom 20 times. And we ended up with 11 over 20. And at that point, one thing I do like to use as an example is if you could see something you can reduce once, like if you could see, say on that 25 over 100, if we could see that first 5, and we could see that it would break down by 5, and we just did it that way. Say, here, let me switch over here. So let's say I had that 25% I was converting to a fraction. All right. Let's see. The light on this thing is so dim that I couldn't tell it was on. I just tried to turn it on and it turned off. That's how you know it's bright. So we have 25% going into a fraction. So we know that we would set that up as 25 over 100. All right, okay, not too bad. But then you have to simplify. Now, yeah, we just went over this and we know that 25 goes into the top and bottom, but what if you couldn't see that? What if you're on your test, you're struggling, you're like, oh God, I can't tell exactly what's going to go in here. That's one thing that happens a lot. If you got a big digit number or you're just kind of frazzled a little bit, you might say, oh God, I can't tell exactly what goes in here. But I can tell something small that goes in here. I could say that 5 goes into each. If you could see at least one thing that goes into the top and bottom, go ahead and do it. Because you could say, oh, 5 goes into this guy 5 times and 5 goes into this guy 20 times. And you would end up with 5 over 20. Now that's not as simplified as it can get, but it's a heck of a lot simpler than it was before, right? So we could actually take that and simplify it even further. Say, hey, I can tell right away that 5 goes into 20, right? So 5 would go into here 4 times and 5 would go into here once, and you would still end up with that 1/4. So sometimes you might have to take a couple of steps, and that's perfectly fine. That's 100% fine. Doing this work right here, if that makes just as much sense to you as going straight to that, then you're good. Same end result, you're peachy. So I just wanted to cover that. Trying to think of something else that'll be 5, 2, 5. I can't think of anything else that's going to break down that I can use as an example. But that is an acceptable method for reducing fractions. So that's one way to do it. And then if you want to return something to a percentage, you just have to make sure your denominator equals 100. So that's not too bad. Let's make another example out of that. Let me see. Trying to think of something that'll break down nicely for that. That I don't use on my examples. Yeah, so let's say I had, let's jump over here. Let's say I needed to convert something back to a percentage, like say, let's do 2/5. And we're gonna take that back to a percentage. Let's do 2/5. That's a nice one. So if we needed to turn a fraction into a percentage, it's actually not a huge amount of work. What you would do, you write out your fraction and you say, okay, well, what would I have to multiply the denominator by, the bottom? What would I have to multiply that by to get to 100? So 5 times 1 is 100. We kind of played with that up here. It was a 20, right? Okay. So if I multiply this guy by 20 over 20, remember I can multiply anything by something over itself because that's a funky looking one that I can multiply by. And we can multiply straight across. Multiplying fractions, you multiply straight across. We get 40 out of 100. And converting 40 over 100 to a percentage is as easy as dropping the denominator and slapping a percentage symbol on there. 40 out of 100, 40 per 100, 40%. Same thing. All right. And of course, I have more examples. I always do. You know, I love examples. So for number 1, let me write it down real quick. So I wrote down 1, 2 right here. Okay. So we're going to take 44% and we're going to convert it both to a decimal and to a fraction. Okay, not too bad. Decimal is really easy from percentage, right? Is what you always do. We're going to find where the decimal point is. If we don't have it, it's always after the integer, after that whole number, right? And we're going to move it 2 to the left. So it's going to end up right there. And again, not always the nicest to just leave it as a 0.44. I'm going to do a 0.44. There's always technically something that's to the left of a decimal. So 0.44 is the same as 0.44. We got that. Now converting it to a fraction, well, we just played around with that a little bit, right? That's not too bad. If we're converting it to a fraction, you put it over 100, and again, we're going to see if we can break this thing down, right? So again, you would look at this and say, at the very least, what's the largest thing I can see that's in common to both the top and the bottom? So what factor would be the same? If we think back to when we were doing prime factorizations, 100, that's 10 times 10. And and 10 is 2 times 5. So 100 breaks down to being a couple of 2s and a couple of 5s, which means that that's the most that we could break down the top with, right? And I see a 4. This guy's obviously divisible by 4, which means a couple of 2s is probably going to work just fine. So let's try 4. Let's say 4 went into the top. 44 divided by 4 would be 11. And then 100 divided by 4 would be 25. You write that down. And if you can keep going from here, you would look at this and say, is there anything further I can do with that? Now, since we have an 11 at the top, that's a prime number. We can't do anything to break this down any further. So that would be this guy as a fraction. That was it as a decimal. It's not too bad, yeah? Decimals, fractions, percentages. Really not a whole lot of stuff to break down. It's just kind of weird to learn it. But once you do, you can look like a wizard. It's great. So let's keep going. This one, we have 14 over 25, and we have to convert that to a decimal and then to a percentage. Now, even though I wrote these, this guy on the left, this guy on the right, it doesn't matter which one I do first. And the reason I'm saying that is 14 out of 25, that might be trickier to find the percentage than this guy, right? If once I get it over 100. Now, there's a couple of ways we can find the decimal. One way is we can actually look at this and say, okay, well, if I converted this to a percentage or to a, if I converted this to a percentage first, then that percentage I could easily turn into a decimal, right? So we could actually work these together. Or if I wanted to do it specifically, remember last time we ended up making that formula, it was percentage times the whole is equal to the part. Okay. Yeah, that'll work. Okay. So remember we did this, and I went over the fact that any formula you use in math, any of them, if you have all of your variables except for one, you can solve for that one. Any formula, doesn't matter what. It's like the whole, when you're younger, you probably converted from Fahrenheit to Celsius and back at one point or another. You have this big awkward formula and it's weird looking. But if you think about it, it had an F and a C in it. It had two variables, which means if you had one, you could find the other one, vice versa. In this case, we have three. We have a percentage, we have a whole, and we have a part. Now, in our case, we have something out of something else. Well, this would be the part over the whole. So based on these two pieces of information, we could find that percentage. So let's go ahead and give it a shot this way. Now, we could rearrange this formula, but I'm going to leave it as is for now. This is how I've been teaching it. This is what we really need to remember. And all you got to do not know is that once you put the numbers where they got to be, you can manipulate them however you need to. So let's chop this percentage guy down to just some variable. Doesn't matter what. Starts with a P, we're going to call it a P. Times the whole. Okay, well, our whole was 25. Equals the part. Well, the part was 14. Okay. And then you just got to think about it. How would I solve for the P? Well, it's multiplied onto the 25. And if it's multiplied onto the 25, in order to undo it, you would divide it from both sides. Now, the funny thing is, you might notice, what did we just do? We ended up rewriting the formula, right? That's what we started with. Now, that's because if I took this formula right here, and I solved it for that word percentage, I would have to divide off the word whole, right? Remember, variables do the same thing that our numbers do. You actually get a formula that ends up saying percentage is equal to the part over the whole. So if you get something where it's asking you to convert this to a decimal or to a percentage, all you have to do is divide the top by the bottom, and it'll actually work out. And that should be, I think, 56. Let me check. 56%. Yeah. Yeah, so if you divide these, what do you get? We get 0.56. Well, there's our decimal. So we could have done that if we had known that this is how the whole thing is going to work out. We could have just jumped straight into doing this divided by that and calling it good. But what I did here is, if you don't know that, and we remember that initial formula I did, you can make any of these problems work. Doesn't matter what. Now, we need to convert it to a percentage. Well, we kind of already did that, right? Because we got the decimal form of this percentage. So we can actually take this guy, and just straight from this one, we can say that it is 56%, because that decimal point would move over to the right. Now, the other option would have been to take your fraction and work it out until you have 100 in your denominator, right? So you'd be able to multiply it by 4/4, and you would end up with 56/100, which again is the same as 56%. Didn't that end up being a beautiful example? I like it. I like it, you like it. The world's still spinning, everybody's happy. I'm happy, I'm having a good day. I got to sign something this morning to accept a new job. Kind of, it is a permanent position with the state in exactly what I've been doing already. But there's a probation period of 2,088 hours. 2,088 hours is the probation period with the state, which breaks down, because of course I did the math. Of course I did. Why would I not? It ends up being a hair over 52 weeks, which is a year. So the probation period is, if you don't miss any days, it's a year. So they're giving me another $1 and change until then, at which point, I don't know if I get benefits now or later, but I'll take it, whatever. I don't care. I want state benefits. That sounds awesome. Just go into a hospital, just be like, all right, fix what's wrong with me. I don't even know. There's going to be a lot. Going to be a lot. Hey, look, this entire slide is what I just talked about. Yeah, and like I said, you can easily divide the left by either of those pieces, and you could find a new formula showing that you could easily solve for those pieces. But like I said, for the purposes of the lesson, we won't use either of these other forms, but you can easily rearrange any formula you use using this method. And there is that nice little guy that we made up at the end of the last. Yep, whole is part over percentage, and percentage times whole is equal to part. Now we had one more on this slide. And of course, I don't know how nicely the numbers are going to work out because I made this up off the top of my head at about 11 p.m. last night. And of course, I didn't work it out. So we're going to see what happens. So Jonah went to the store to purchase 62 watermelons for his 13 chickens on a watermelon only diet. That's literally the first words that came to mind. Assuming each chicken eats half a watermelon per day, big chickens, what percentage of watermelon is gone each day? I guess I should say our watermelons. I accidentally left my my question open for a trick answer of half. What percentage is gone each day, and how long will these watermelons last with these chickens? All right. Yes, I made up a weird problem. I have no regrets. Let me write down some of our necessary pieces of information. We have 62 watermelons. We have 13 chickens. And each chicken eats half a watermelon per day. Then we're asked what percentage is gone each day. And how long will they last? Okay. So the way that I took notes on that is I just took all the essential pieces of information. You're doing a weird word problem, you just need some parts of it, right? So we have 62 watermelons, 13 chickens. We know how much each of those chickens eats per day. We need to know what percentage is disappearing every day. And I mean, think about it. It's not going to magically change each day by day by day. It's like we're just looking at what percentage is gone. I guess I should say our second day. And how long are they going to last? So until you have 0 watermelons. Now, thinking about what we know, the percentage one, because usually these types of problems, you should really brainstorm a little bit before you just start throwing stuff at the paper and seeing what sticks. The percentage one isn't going to be too bad because all we got to do is figure out, you know, how many watermelons are going to be there our second day. And then we can figure out what percentage difference that is. Hint, hint, that'll be the next topic on the review. Our percentage difference, that's going to be. And then the how long will they last? That one's going to be just essentially as easy as like simple subtraction or division, if you want to look at it that way. We can figure out exactly what that's going to be by breaking down how many are gone every single day versus how many we started with. So let's look at this guy. Let's say this, for the purposes of making our lives a little easier, let's say that's A and that's B. That's one thing I always tend to do. I just kind of do it that way. That way I can put on my paper that I am working on A, and that's where I'm going to look when I'm talking about that one. So what percentage is gone each day? Okay, well, we start off with 62. And then for the second day, we're losing half of a watermelon per chicken, right? So if each chicken is eating half a watermelon, to find that, you can multiply the 1/2 times how many chickens you have, because each one is doing half of one. So if we work it that way, we can figure it out quite quickly. So half of 13 ends up being 6.5, 6.5. And we need 62 minus 6.5, which is going to be 55.5. Now we need to know what percentage of our amount did we lose since yesterday. So we need to know if we're measuring our difference, we need to figure out what our difference is, right? Like we need a solid number to say, this is how much is breaking down. Now, that ends up being the 6.5, right? Our first day, we lost 6.5. In fact, every day we lose 6.5. So there's actually going to be two ways we can work this out. You can measure the difference. You end up with that one. And then you find percentage of the difference. And if you remember finding the percentage of a piece of it, you're going to put the part over the whole. Now, the other way to have found it would have been to say, there's another way to look at it. You could say, how much do we have left? You can figure out how much we have left by doing that, and then figuring out the difference between that and 100%, right? Because if I have, say, 80% right now, then that means I lost 20%. So I could very well just do 100% minus that guy. And that would also give me my answer. So you know me, I like doing things two different ways. Let's do both. So we have 6.5 over 62. That ends up giving me 0.10484 or so. I'm just going to take a bunch of decimal places. Now, if I'm being asked what percentage is gone in that day, I have to convert this to a percentage, right? So that guy's going to go over 2 decimals, and I would have 10.484%. Depending on how I might do it, I might round that to 10.5. In this particular case, I'm not too worried about it, but depending on your word problem, it might say, oh, round to the nearest thousandth, round to the nearest tenth, round to the nearest integer. So just be careful of that. And that again is why I don't round until I hit the point where I have my percentage already. So if I round up here, I'm going to be rounding to 2 digits that I'm not accounting for yet. Now, if I did it the other way, I'd have 100% minus 55.5 over 2 or 62. I mean, think about it. If this is going to be 10 and about a half, then this is going to end up being a little less than 90%, right? Which it does. It ends up being 0.89516. Now here's a fun thing. If I converted that percentage, 100% to a decimal, I know I've said it before, but here it is in action. 100% as a decimal is just 1. Just 1. Same as a 1.00. It's 1. Now, if I subtracted that, guess what I'd get? That. So in this case, which one's easier? Obviously, this guy over here on the left, right? That one's a lot easier. So why would I show you both ways? Well, depends on the problem. They don't always ask you, hey, what is your percentage difference? Sometimes they might say, how much do you have left? What is the discount amount? What is this difference? And you could say, oh, well, I know how to find what I have left. And by doing it this way, I found both. I know that I have 89.516% left. And I lose 10.484% each day. Now, want to do this or do I want to make it C? Now, as a random aside, you notice that I changed my wording on the problem right away, right? That's because I saw a huge flaw in how I phrased it. The huge flaw I wrote is what percentage is gone each day. And the reason I'm saying that's a flaw is because the percentage is going to be different every day. See, after our first day, we have 55.5 watermelons left, right? So we could say on day 1, we just bought them. Day 2, I have 55.5 watermelons. But let's say we had a random question of what percentage is gone day 3. And this is why I changed my wording on the problem, because I noticed that this was going to be a huge error on my part if I didn't. Because on day 3, well, remember, how much are we losing? Every day we're not losing chickens, we're losing the watermelons. So every day we're going down by 6.5, but out of what? I always say it's the part over the whole, but we don't have 62 watermelons, do we? We have 55.5 watermelons the next day. And suddenly that's a completely different percentage. 6.5 divided by 55.5. Funny enough, that repeats on forever with 117 going all the way down. But that ends up being about 11.7%. So it actually is going to increase in percentage every single day. So that's why I changed my wording, because it's not going to lose 10% of it every day, because every single day we're going to have a new whole, a new amount that we're taking a percentage out of. Now, what we're not going to be able to change is how long are they going to last? So I just kind of like, I'm a nerd. I like the symmetry that's going to happen here. Because if I'm gonna work on B and I'm gonna say, okay, well, how long are they gonna last? How would we figure that out, right? We could sit here and say, oh, well, I have 62 watermelons and I could subtract that I'm losing 6.5 every single day. And I could do that over and over and over again until I figure out exactly how many times 6.5 happened to go into there. But think of how I phrased that. I'm figuring out how many 6.5s go into 62, right? That's literally division. So I'm actually going to be doing 62 divided by 6.5. And that's why I chuckled, because we did 6.5 over 62. And that was the answer for A. And then the answer for B is 65 over 6.2, or 62 over 6.5. So you just punch that in and you'll figure out how many days we're going to have. So we end up getting 9.538 or so. So we're not going to measure, we're not measuring out per meal or anything. We're not separating these out. We're talking about days. So since we're working with a word problem, we want to remember that we want to be able to answer the word problem the best way we can. So how long are these going to last? Well, I don't want to say 9.5 days, because I'm only giving the chickens half their meals, right? So at that point, you would actually, it would be implied on how long will they last. You would round down to the nearest day. That's the only way you can do it, right? Because you're not going to be able to measure this in thousandths of a day. You don't have enough for that full meal right there? Cool. It's going to last 9 days. After that, you don't have enough for a full day worth of meals. Well, that ended up being a substantially larger problem than I expected it to. My bad, guys. And this is why you be very careful about feeding all of your chickens so many watermelons. I have to watch that myself. I know my cat only eats 4 or 5 watermelons every day. I think it'd be interesting to have a standardized size of watermelon, and then we started using that as a unit. What we could weigh ourselves in terms of watermelons. Already done that. There we go. Boy, I love examples. Boy, I love examples. Everybody's taking pictures of the slides. I'm giving y'all a second. I know it's convenient to glance at the phone, but don't forget, I do have all of these uploaded in the Google Drive folder that I sent out in an email, so you can always click on that. And I think you can even Yeah, you can even download this as a PDF. You could print it. And these are available for you guys to view anytime. Yeah. So we have more examples because I'm insane. And I think I actually made too many examples, didn't I? Let's see. I think for this slide, because I want to be able to get to the newer stuff, let's only look at number 3 for now. I think number 3 is the best one to take a look at. The other 2 are examples of something that we've already worked on tonight. We've already worked on finding what the percentage was. We've already worked on finding a percentage of something. I think we've actually worked on figuring out something like this. So let's say that you got paid. It's a part-time job, so it's just a little side amount of money, but they took out 16% of the check. So you're actually left with 145. You're being asked what was the paycheck, what was the original amount of paycheck, what's the gross that you just made. You can look at that and say, okay, well, this would be the percentage, obviously, and this would be part of the paycheck. And if I have percentage times the whole is equal to the part, the only piece I'm missing is what was the whole? What did we start with? Well, let's slowly fill in the pieces we have. We have 16% of something. We don't know what. It was our paycheck. It was our gross. I'm just going to use a G. Doesn't matter what variable you use. I'm using G for the gross value. And it's going to equal the part, 145. Okay. Well, all I have to do is clean this up a little bit, right? 16%, convert it to a decimal. So that's going to be 0.16. That's multiplied onto a variable G, so I could just write 0.16 G, same thing, equals 145. Now, since they're multiplied, in order to cancel it out, we're going to have to divide, right? So divide both sides by 0.16. You get your gross amount is the part over the percentage. So if you go back a few slides, that was one of the formulas. It doesn't make as clear sense as it does as the one where it's the part over the whole is the percentage. This is kind of funky. So a lot of times if I'm doing these types of problems, doesn't matter how good I am at math, I'm probably still going to write it out this way to kind of understand it a little better, you know? So 145 divided by 0.16. Oh, wait a minute. I made a mistake. Yeah, this whole thing blew up. You know why? This whole thing is incorrect. There's a very clear reason. I didn't notice it. Anybody else notice it? No. I had 16% taken out. And I said I had 145 left, which means the amount taken out is not that 145. I just found what amount 16% of that is to be 145. So what we actually should have done is figure out what we actually have. We have 145. We need to know what percentage that is. So you would do 100 minus 16, that would be 84%. You need the percentage that correlates to this part. This percentage has to be related to that part. Never shy away from your mistakes, own them. Learning experiences. Look at how badly I screwed that up. Imagine you got paid $906 and they're like, oh, we're taking out 16%. Okay, all right, here's 145 bucks. Wait a minute. That's how I knew I had made a huge problem. Always look back over your word problem and be like, does that make sense? No, that does not make sense. That does not make even a little bit of sense. We should have had 84% of our gross is the 145. 16% of our gross, we don't know. That got taken away. We didn't have a clue what that was left with. We could actually find it in a minute. We could see how wrong Ben was. In fact, we're going to. That sounds fun. So following the exact same steps that I did when I was horribly wrong, the method was right, the setup was wrong. And let's face it, that's usually what happens with word problems, right? Oh yeah. So again, how to solve that particular problem? Look at your answer and say, does this make sense to the question? If it's an oh God, no, go back to your setup. Figure out where you made the mistake. And that was a very big spot for the mistake. See here, this is going to work out a lot more nicely, because since those numbers, since that 0.84 is closer to 1, since it's a larger number, this is not going to be as gargantuan as this one. If you take a big number and divide it by a very, very small number, you end up with a very, very, very big number. If you end up with taking a decent sized number and dividing it by something, it's kind of smallish, you end up with something a little bit bigger. So in this case, we end up with 172 point, I'm going to round it to the second decimal point because we're talking money. So $172.62. That would have been the paycheck. And you can look at this and say, does that make sense? Yeah. Yeah, so that's, well, it doesn't equal the 16%, that equals our paycheck.
Okay. Okay.
See, my problem was, I was looking at that 16% and I was saying, oh, that correlates to one of these numbers. It doesn't. It correlates to something we don't know. It's 16% of what? I don't know. Whatever our paycheck was. Now we could figure that out. We could figure out what was that 16% quite easily, right? We could say, okay, well, now that I know how much the paycheck was, I can take 0.16, the decimal form of that 16%, and I can multiply it by that paycheck, because that 16% was from the paycheck. So 0.16 times that guy, we end up with 2762. The other way to have found that would have been to take the difference, this guy minus the 145. But that didn't seem as fun to me. I wanted to go percentage wise. Making some notes for when I scan them later. So if anybody wants to look back over this, you can look at this and be like, what did he do to mess up? Oh yeah, he had the wrong percentage. So despite my horrible mistakes, does that make sense to everybody? Are these kind of working, kind of tracking? So further stuff, percentage increase and percentage just decrease. We've already played around with that a little bit, right? It's really just the concept that you got to get down for these, because the work itself is exactly the same that we've been doing all night already. The work itself is exactly the same. It's just the idea of percentage increase and percentage decrease. It's literally, hey, I got a 10, like a raise from this amount to this amount. Okay, well, what percentage did you just make? You're not gonna do the math and say, oh, I got 112%. No, that'd be awesome as a raise, but you just got 12%. So in this particular case, well, how do you find the percentage of the raise you got? Well, you figure out what the difference is. You figure out how much of a raise you just got, and you always divide it by your original amount. So you started out with 1228, so you're going to divide it by 1228. So you're figuring out what percentage that $1.47 extra you're getting is of your original amount. You get 0.1197, really, really close to 0.12. So you can say, okay, I got a 12% raise. Not bad, not bad, buddy. 12% is good. I mean, they make more at Target, but you know. They make more at Target than I make at the state. Now, discounts are the same as a percentage decrease, except usually you're talking about dollar amounts, right? So in this case, if you have something that's $14.99, but it's 15% off, you might be asked a couple of different things. How much is coming off? What's the discount amount? And then what is the current amount after the discount? What is the discounted price? So you would say, okay, well, if it's dropping 15%, what's 15% of what we started with? Okay. So you multiply the 0.15 onto the $14.99 price, you get $2.25. All right, so that's the discount amount. It's going down by $2.25. So what's the current price? That minus $2.25. So it's not bad, right? It's not bad. Already played around with that a bit tonight. I don't know that I'm going to do all of these, but I'm really proud of them. I feel like number one's the most useful, but I'm more proud of my writing number 2 and 3. Bill Murray really, really regrets Garfield. Or Bill Murray. He hated himself for Garfield. You know, one random, this is the most random and pointless fact I know. Oh, that's probably a lie, I know more. dumb facts. But when they made a Ghostbusters cartoon in the 80s, they had different people voice him, obviously. The guy who voiced Bill Murray's character is the guy who was the voice actor for Garfield in the Garfield cartoon. So I find it hysterical that that guy voiced Garfield and then later Bill Murray voiced Garfield. It's like, cool, you've both been the same two characters. One of you obviously lost out though, because you made a god-awful movie. Yeah. I like number one. Let's do that. So we miss out on a sale and the price jumps back to 700 from 460. What was the percentage the sale was for? All right, okay. That's not bad, right? We've done this before. We haven't done it with this exact wording. But what do we know? Well, right now it's 700 and it ended up having been 460 on sale. This is its original price. This is the sale price. Hey, look, the word's whole and part. Weird. This driven into everybody's skull yet? Sufficiently? Percentage times whole equals part? Yeah. Good stuff. All right. Well, I don't know what the percentage is, but I'm going to multiply that by the whole and get the part, which boils down to dividing both sides by 700, and I get 460 over 700. .657143. So if I convert this to a percentage, I'm going to move it over a little bit and we'll have 65. I'm going to round it to 65.7%. But the question is, am I done? Well, I figured out what percentage this was of this. But what am I being asked? What was the percentage of the sale? What was coming off of this guy? Well, this isn't the discount amount. This is how much our sale price is of our original price. So this is just what we have left. So this wasn't 65.7% off. That's what you end up with left, which means the difference between 100% and that guy is going to be the actual discount percentage. So I end up with 34.3%. Which makes more sense when I look at this and say, oh yeah, going from 700 to 460, that's less than half. This is less than half. So it makes more sense than saying it's more than half off, right? Cool. Now, do we feel we're doing good on percentages or do we need to move on? We need to do more? Do we need to do 2 or 3? Nobody online speaking up? I feel like that means that you understand percentages perfectly. everything is making perfect sense. Is everything
Well,
making perfect sense?
Not really. I don't know. You can do maybe like 2 more.
Okay, now, if you're getting thrown off a little bit, are the word problems what's throwing you off? Or if I went back to say something,
The one is 16% and G.
oh yeah, the one I screwed up a minute ago.
Yeah.
Oops. Okay, well, let's at least, I'll do some more. I'm just gonna go ahead and finish off those examples, but let's review this problem one more time.
Okay.
So the idea was that we got paid, we had 16% taken out of our paycheck, and we left $145. So that's how much we took home. So the idea is, well, what did we start with? So in order to figure out what we started with, the correct way to do it, the 0.16G, I did wrong. Because what this would have given me is this would tell you 16% of something is 145. But the reason that's wrong is because 16% of something we don't know.
Okay.
16% of something we have is what came out, and we have the 145 left. So what we actually needed was the percentage we had left. Let's see, yeah. So the couple more percentages ideas is quite popular, I see, okay. Yeah, we'll do some. In fact, I'll do a few more and then I'll ask again. And if because remember, I skipped a few earlier too. I could always go through those. So we had to figure out what we had left. So 100% minus that 16%, 84%. This correlates to the $145. You need the percentage because we're putting this 145 in the formula. We need the percentage to be what this number is. We need to know, hey, what percentage of this is this 145? It wasn't 16, it was 84, because once we took away 16%, that's what we would have left. So if 145 is what we had left in dollars, 84% is what we have left in percentages.
Okay.
That's what was important there. And then you can divide off the 0.84 and you get what your original paycheck was. Now, I realized that I had a huge error because I got over $900. And if I got paid something and they took out 16% and I had 145, if I got paid $900 and I got stuck with 145 after that, that is not 16%. That is a tiny number.
Yes.
Compared to that. So that's what I wanted to drive forward on this problem. On my mistake is sometimes it's very good to look at your mistake and say, does that make sense? Look at your answer, look at your question. Does this make sense? No, this makes no sense at all, which means something was wrong either in my math, which was unlikely because I did very few steps, or my setup. And my problem was I had the wrong percentage.
Okay.
So we had to do what we had left, so I worked that out. Now, in terms of more problems, I always have more problems.
That's would be problems.
I know, right? You know, it cracks me up. First of all, I just out and decided I'm not going to use that workbook that got handed out at the beginning of class. I know I've said I'm going to go back to it, but honestly, I've thumbed through it. I hated it. I hate that book. If you guys need a little more practice, it is perfect to go through. If you're at home and you want something to work on it on your own time, glance at it. If you see a problem that you are like, oh God, what? I don't understand this. This is weird. Tell me, we'll go over it in class. Because if you don't understand it, if one person doesn't understand it, chances are most of you aren't. And that little book is weird. The thing that cracks me up, that got me on that weird little tangent, is talking about a test. That the green book that those worksheets actually come from, which is what I thought everyone was getting at the beginning of class, I was horribly wrong. That's a lot more expensive. The green book they all come from has a practice test in it. Well, I have the old edition of that book, and I compared it to the new edition of the book, and I noticed a huge difference. They took out something from trigonometry. Now, did they retool the whole book to fix this? No, anytime that came up, they just deleted the problem. And that for some reason, the new version of that book has a sample test of 39 problems and a practice test at the back of 49 problems. And it used to be 40 and 50 because they didn't even bother trying to even it out. It was like, delete it. Okay, sell them this now.
So is it just this one?
Yeah, that was just the one.
And these two are for,
Never seen them before.
this is the one that you said you wanted to start, but.
Yeah, that's the one that was given out for the class. I imagine every single one of them is wildly useful for you. And for the record, even though this class is ending in what, 2-3 weeks? 3 weeks? If you guys are working on anything, oh, I see what you're talking about, Kelly. Yeah, there was a workbook that was handed out at the orientation, but you had to go into the main Excel room to pick that up. I feel like not everybody did that, but I'm also going to say that it doesn't really matter because I never ended up using it. I like the structure on the Essential Ed website. I know I've said a few times for everybody to try to go on there and try to work on stuff. But the workbook that was handed out at the beginning of class does not spoon feed you anything. It assumes that you have a decent understanding of all of this stuff and that you're jumping into it. So after this class, it is perfect to get into. Perfect to browse through and flip through and do those problems. It's perfect to do that. But until you have a solid foundation of this stuff, it is a horrible book. If you don't know anything, that is, yeah. If you don't know anything, that book just throws, like the first page has, I think, fractions and percentages and decimals and everything all in one problem. On the number lines. Like, that thing goes from like number lines to really advanced geometry in 20 pages.
Oh, okay, yeah, I don't want that then. I'll just
Exactly.
continue doing the online thing.
Yeah, the Essential Ed is great. It spoon feeds you all of these concepts. It builds up. Like I've tutored at WNC since 2008, and I've seen online, because they tried to do the online homework. Some of them suck, some of them don't. I really like the way the Essential Ed actually structures everything, and that's actually how I've structured this entire class, is based on the Essential Ed lessons. Everything in that workbook does not compute perfectly to that. We are going to cover everything in there, but you got to know the whole class before you start doing this. And what I was going to say is, after the class is done, first of all, nobody's emailed me with any problems. I said that at the beginning of the class. If you guys have any of these math problems you're stuck on, or you're doing the Essential Ed and you're thrown off, or you don't understand something, email me, contact me, however you got to do it. I will help you. I don't care if I'm still teaching this class, if you're still in my class afterwards. If a year goes by and you see that my email is still active and you have a question, freaking ask me. I am down. I am okay with that. So if you guys are because the idea with the foundations class is after this, you're going to end up going into the online portion. Like there's a separate class that they're working on. I'm not as familiar yet. Everybody else is working on that, and I'm just kind of showing up here after work to work more because I'm insane. But yeah, if you need help at any point during or after this class, message me. If I'm at work, I'll reply that I'm at work, and I'll reply later. But yeah, no, we're gonna figure this stuff out. Speaking of figuring things out, who wants to do more percentage problems? Yeah. Yeah, I didn't intend to basically take 2 full days on percentages. I wanted this to be like a quick intro again. But yeah, we're totally just rocking a bunch of percentages tonight. We'll get to the charts. The charts will come later. I truly hated setting up all of those charts. Putting all of this in this. I had to figure out how to make a pie chart, man. I hated this. I hated this. I've never seen this. I've never seen that. That I've seen. These I've seen. That everybody's seen. Those are ugly. But I mean, the hell is that? So yeah, at some point, we are going to get to all of these because it took me like 3 hours to put all this in here. So yeah, I hate, in previous classes, I've literally just skipped that entire section. It's a graph. You can look at a graph and understand what's happening, right? You see the bars, there's bars, and you look at the bars and, oh, which one's highest? Is that one that's highest? Okay. You know, you got the idea, but we do need to actually work on the reading and the comprehension of them. So, you know, I figured for this particular, the foundations class, I would not skip it. I would just hate my life working on it. Okay, everybody tired of my rambling and whining? All right. So let's look at some more percentage examples. Number 2. Yeah, cool. Got this here. All right. Bill Murray got bored. We got a part-time job working at Starbucks. He's given a raise from $12.50 an hour to $13.45 an hour. What is the percent increase he's gotten while still regretting his voice acting job in Garfield? Okay. Write down what I need to know. Number 2. Yeah. All right, no problem. Well, despite my terrible handwriting, we have $12.50 and we're going up to $13.45, and we need to know what percentage increase did we just make. So I'm just realizing this is very close to the sad little raise that I'm about to get at my other job, except I already make less than this. Man, I should have just gotten a crappy job at Target. All right. So we're going from this amount to this amount, and we're looking for the percent increase. So when it comes to the percent increase, again, we always want to take it, you know, we're going to end up having the part over the whole, but the whole is always going to be what we started with. Now, the reason for that is, if you remember that problem I did earlier where I said, oh God, I made a mistake in my wording, and I went from each day with the watermelons and the chickens that made no sense. If we go from, I changed it from each day to the second day, because every time what you have changes, then the percentages would come off of a different number. So it ends up changing the whole formula. So we always want to make sure that when we're figuring out a percent increase or a percent decrease, we're figuring out based on what we started with, not with what we ended up. We definitely don't want to end up with the 1345 at the bottom here, because if we do that, then we're figuring it out based on the percentage of what we make now. That wouldn't tell us anything about how much we make more than we used to. We're talking about how much more we make than we used to. We're going to talk about what we used to. It makes sense. It works. So in order to figure out what our percentage increase is, we need to figure out what the part is going to be, right? We need to know exactly our dollar amount of increase. Well, that's not bad. Let's figure out, let me see I'm going to call this the increase amount. And we're just going to subtract them, right? We're just going to figure out what the difference is. What do we make more now than we did before? That's what, 95 cents? We got a whole 95 cents more. Yeah. You know, fun thing about that is if apparently you work 2,088 hours in a year, you just made about $2,000. I like that 95-cent raise. I want a few of those. It seems like a little bit, but it's a substantial increase. So, okay, well, we need to figure out what the percentage was. So what percentage is 95 cents out of that 1250? Well, easy. We just figure out what 0.95 is out of our 1250. The part divided by the whole. All right. So we're figuring out what percentage 95 cents is of 1250. And I get 0.076. If I move that decimal point over 2, I get 7.6%. Which coincidentally is the tax rate in Carson City. I mainly have that memorized from my time of selling video games. I hate when can you ever go back into a store that you used to work for and somebody tries to talk to you and you're like, I know more than you. I don't do that. The staff at my old store is very nice. I like them. They're not idiots, which is hard to say about retail. Unlike Little Caesars, I went there the other night and I got my order wrong. How do you screw up an order when you got like 5 things on the menu? You know how? The guy who screwed up my order used to be a problem customer of mine at GameStop. I am not surprised he managed to screw up an order at the Little Caesars. I don't like that guy. All right. It's like I recognize your face anywhere because I remember you complaining. Okay, so the other one, you have driven a car off the lot. The value has immediately changed from 20,000 to 3,500 since it's now used. What's the percentage decrease in this sad reality? So 20,000 going to 3,500. And we want the percentage decrease. Okay. All right. So, like any of these other problems, if you notice what we're going to end up doing, up here, in order to figure out the percentage increase, we had to figure out the amount it's increasing. And then we found the percentage that was of our original amount. That's exactly what we're going to do here. We're going to figure out our decrease amount. So we're going to figure out our difference, which is going to be 20,000 minus 3,500. That's what, 16,500. We figure out our decrease amount, and then we're going to divide that by what we started with. So it's the exact same method. That's one thing that always bothered me when I was taking these classes. They teach these half the time as completely different methods. They are very clearly not. I am doing literally the same thing in both cases. You figure out the difference, and then you divide it by the original amount. And that tells you how much you've changed. If it's gone down, it's a percentage decrease. If it's gone up, it's a percentage increase. Simple as that. And then for the ease of calculator use, I like to cancel out my zeros. So we have 165 divided by 200. Thank you, calculator. My calculator is a jerk. It just reduced it to 33 over 40. So it is 0.825, right? Shift that over. We have 82.5%. Now, one thing I haven't mentioned, it's kind of, you probably picked up on it, but it's kind of like just unsaid. But notice that when I'm playing around with percentage amounts, we really only start with those or end with those. When it comes to actually doing the math, you pretty much always are using the decimal versions of the percentages. Now, the only time that's going to change is, say, if I go back to the one I screwed up on, when I had to figure out what we had left, I had to do 100% minus 16% because that was purely in percentage. But when I went to actually do the math, I needed to use the decimal amount. Every single one of these, I'm using, we end up with the decimal. We end up with the decimal, end up with the decimal, 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 blah, blah, blah. You generally don't use the percentage amounts when you're doing the math on these problems, because you will end up with 100 times what you're starting with. How likely is it for you to make that mistake? Not very. I'm usually pretty careful, pretty good about making horrible mistakes all the time. Case in point, I've done it twice tonight already. That's one I've never made. How likely are you to make that mistake? I haven't screwed it up. You're probably not going to. I am adept at making mistakes. All right. Let's just round out all of our examples, right? Let's finish them all. Do some more. This is what I did. Yeah, number 3 is the one I screwed up on. So number 1 and number 2, I haven't had a chance to screw up on yet. Those are great. Let's do those. So the first problem is saying that we want to know what 56% of 532 is to the nearest integer. So that's not bad because this one is literally just a direct application of our percentage times whole is equal to the part, right? Because we're asked for this percentage of this amount. That's literally the formula, right? So I would convert the percentage to a decimal. So 0.56 moves over twice. I multiply that by the whole amount, 532. And we're going to end up with, well, whatever this is. Now, if I punch it in the calculator, I end up with 297.92. But the question is, we got to round it to the nearest integer. So decimals, not going to do it. So if I had to round this to the nearest integer, well, I would look at these decimals or these place values, right? I would look at these and say, okay, well, what's the closest here? Well, the next digit's a 9, which means this would round up. So we would have about 298 as our integer. Okay. Number 2, question was, we have some random puzzle that we got. We have fumbled the box. Somehow a bunch of pieces were destroyed. Huge amount of pieces. You have 345 pieces left. The question is, what percentage did we just lose? So based on what we've learned, there are a couple of ways of doing this. Now, if I actually had this problem written before the percent increase and the percent decrease, but you can tell this is kind of a percent decrease problem, right? We're going from 550 pieces to 345 pieces. So if you want to, we can do this strictly as a percent loss problem. Now, the other way to do it would have been to figure out, well, what do we have left? And then take that off of 100%, like we did that earlier problem, but that did take a lot more steps. So I think we're just going to keep treating this as a percent decrease problem. Because that's going to make our lives easier. And if there's one thing we want to do, it's make our lives easier. I like that idea. So just like all the percent decrease problems, the percent increase problems, we need to figure out what the decrease amount is. So we're going to take our original amount and subtract the 345, and we figure out how many puzzle pieces we've lost, right? Which is what, 205? That puzzle's toast, just throw the whole thing away. So we have our decrease amount. Now we're going to do the same thing we did on all of those other problems. We take that decrease amount and we divide it by our original amount. Now, is our original amount 345? 550, yeah, right, exactly, because you always go with what you started with. In this case, even though we started with the phrase 345 pieces left, we started with a puzzle that had 550. So you do that, punch it into Mr. Calculator. You get a label or a sticker or something and just put it on my calculator. It says Mr. Calculator. And I get 0.372727. It actually does that forever. Because remember, when we learned rational numbers, so it could be a rational number if the decimals repeat. Well, this one repeats perfectly. It repeats forever. Now, if we go back to the original setup, if you look at the slide, I also said round to the nearest thousandth. Now, one thing I do want to point out, we are not going to round to this point right here. The reason being, we need to convert this to a percentage first. So if I convert this to a percentage first, then this is the point that I'm going to look at, right? Because it's going to be the third point, tenths, hundred, that's thousandths. It's going to be the third decimal after that. So I'm going to have 37.27. And then the next digit, is that going to be a 2? Or I look at the next digit, I have a 7, which means this is going to round up to a 3. So we have 37.273% of our puzzle is lost forever. Oh, poor puzzle.
Sort of agree.
Yeah,
Just can't.
just huck the whole thing, yeah. Just gone, whatever. It's cool, I'll buy another on Amazon, hail Bezos. Whatever. Okay. So are we feeling better about percentages? Everything kind of a little more clicking? Are we feeling okay? Everybody all right? Okay. So I'm tired. I want a break. Some of you might too. I'm mainly thinking of myself in this case. I'm selfish. So what we're going to do is we are going to take a break. I like doing this. This is convenient. Break until, I don't know, what time is it? 7:37? Let's say 7:50. Nice and round. We like that. Make it huge. There we go. Am I sharing that? Yeah, I'm sure. Okay. So, yes. Yes, I am recording this. I did screw that up once, but I haven't uploaded anything since then, so I should probably get around to that. All right. So I'm going to mute this and I'm going to stare at my phone for a little while and take a drink, and you guys can do what you got to do. All right, who wants more math? Yeah, everybody. Oh yeah, we're giddy. What is this? Explore? I don't know what this does. I've never pressed this button. I'm going to press this button. What's the button do? Yeah, I don't care. That's stupid. All right. I don't want to do it. I mainly wanted to know because it's in the way of my table. Hey. Okay. So speaking of tables, reading and interpreting tables. So we're getting into the charts and tables section of the math stuffs. So I imagine everybody's got a rough idea of what a table is. They're, other than the ones that are made out of wood. In charts, they are made up of rows and columns of data. They're usually used to summarize information in a way that's hopefully easy enough to interpret. So if you know how to read a table, you can tell what information the table's giving you. Now, what I have here is a neat little table of population values from 2011 for countries in Asia. So based on these, you could compare the data in any way you please. So you could say how many, if you could ask the question, how many more people are in Pakistan than Japan, you'd be able to see the population amount, subtract them really easily. if somebody asked you, you know, how many countries had a population under 200 million, you could see that right off the bat. There's 3 at the bottom, that sort of thing. Now, for the most part, I have 1 slide on each type and 1 slide with a bunch of questions on each type. In this particular case, I got a big ugly table. That is a big ugly table. That counts as a big ugly table. I actually took the previous table out of this data. So in this particular table, we have a list of very populous countries, which continent they're on, what their population is, and the world population percentage. And that one is just how much of the world happens to be in there. And again, this is all data from 2011. So obviously there's more humans now than then. So number 1 says how many countries are in this table. Well, that's easy enough. You just count the rows, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there is a grand total of 10 countries on the table. Makes it really easy for finding percentages and stuff if you got 10. Okay. Number 2, which countries have over 1 billion people? Yeah, 2. Because the nice thing is this table is actually already sorted by population, right? So the only 2 that have a number over 1 billion are China and India. Which country has almost 20% of the people in the world? Well, that one's going to be China, right? You can see in the world population percentage column. That one's sorted by amount also, because I mean, it would have to be. And that number is awfully close to 20%. Okay. How many people live in the USA? 314 and 433,000. All right, 314 million. There's a few. How many are voters? I don't know. We don't have that much data. How many of those voters get thrown out immediately before every election? A lot. A concerning amount. What is the most populous country in each continent? Okay, well that's easy enough. So what you could do at that point is it's asking for the largest population on each continent. So you could start with your continent column and start working your way down. In China, the one with the highest population is the top one, Asia. Or in Asia, it's China. Ha, I got that backwards. The next one down, North America, we only have 1. We skipped Canada. There aren't that many people in Canada. That would have counted too, but the US has the highest percentage in this particular continent. The next one down would be South America. Gotta stop screwing with this table. Oh God, what did I do? I got an A and then J. Here we go. South America, that country would be Brazil. That one has the highest population down there. Next one down is Africa. That'd be Nigeria. And then Russia's kind of tricky. It's counted as Europe/Asia because it's kind of all over the place. And if they have their way, they're going to eat more of Europe. Got a couple 100,000 troops on the border. He's like, I'm not going to roll over on them. It's cool. It's cool. We're just buddies. We're just buddies. We're just hanging out. Never let the leader of your spy organization run your country. Run. Run all of you. Okay. Number 6, which continent contains the most populous countries? Well, we're going to go ahead and go with Asia, right? Because the top 2, China and India, are both in Asia. And of the 10 most populous countries, how many are in Asia? At that point, you just go to the continent column. We know there's 10. Number one, how many countries are in this table? 10. So we could just count how many times we see Asia. 1, 2, 3, 4, 5. Do I want to count Russia? I don't know. 6. And Japan makes 7.
6.5.
Yeah, 6.5. I don't know. Russia kind of counts. I don't know. Not the clearest data. Not the clearest way to answer that question. So yeah, that's how to read a table. Does anyone have any table questions? Is it mahogany? Is it oak? No? Okay. I think we all know how to read a table. We get the idea. They give you a table, you can generally pull the information you need off of this table. And the same sort of thing happens with circle graphs. Normally we're calling pie charts. So circle graphs are an important kind of graph, and they're one of the most used. Circle may be 360 degrees, but graphs, I should say circle graphs, use percentages. That means in a circle graph, a full circle is going to be 100%. So at no point are you going to have, every once in a while, you'll see the news use a circle graph, and whoever's making the graphics, you can look at it and be like, oh my God, you're an idiot. All of those add up to more than 100. If you have percentages, you better be going out of a total of 100%. You're not going to be playing around with 110% of a population, 110% of the money you have. You can't conjure an extra percentage out of nothing. So that's why circle graphs are out of 100%. So the sectors always end up kind of looking like a slice of a pie, which is why you call them pie charts. Circle graph can be used to give you information about a topic broken down by different segments of a whole. The whole being the whole circle graph. And here on our next slide, we have a circle graph of how much I want to make a pie chart by day. Notice I have the subtitle by day. And it's kind of moving, it's starting up over here in the upper right, and I've noticed it's kind of moving in a clockwise way. So on Friday, I wanted to make a pie chart, 43%. I was like, not happy about it, but okay with it. Saturday, 32%. My interest is waning. Sunday is 17.5. And Monday, oh no, I did not want to. I did not want to. But I did. I figured it out. I made this pie chart in Google Sheets. Yeah, Google Sheets. And then I copied it into Google Slides. Do I have Microsoft Office? I sure do, but you know what? This is quicker, so whatever. So let's say I have units called watts. Now I made up this random unit because I realized that I have percentages here, but I didn't have percentages of anything, right? Anyway, if I have 43% of how much I wanted to do something, what does that mean? That doesn't mean anything. So I made up a unit. I have units called watts. I'd say I started my weekend with 475 of these units. So how many of these did we have on Friday? Well, we've played around with enough for percentages. We don't need to switch over to our notes for that one. We want to figure out what percentage is. Now, I know it's kind of small, but there's a 43% on Friday. So we want to know what 43% of that 475 is. So to do that, you just multiply. We're going to do 0.43 times 475. We get 204.25. So let's round it, say about 204, right? Okay. So how many less did we have on Monday since Friday? Okay. So we're comparing Monday and Friday. So let's keep that number in our head. Friday, You know what? I got a nice way to do this. Let's actually do it in the notes. I like it. I thought of something. Improvising, yes. So what I'm going to do I mean, really, I kind of want to just did it wrong. I kind of want to just talk about this in terms of just keeping it in your head, but let's face it, we're going to get a little jumbled, right? So if we're going to get a little jumbled, maybe it would help if we wrote down and organized our information. And what better way to organize our information than putting it in a table? Hoo-hoo-hoo. Hoo-hoo-hoo. So we're going to make us a little table. We're going to improvise. So what I'm doing here is I'm going to make a table for our circle graph. And all I've done so far is I've written down my days. Now, each of these days, we're going to have a couple of pieces of information, right? We already have our percentages. There's my lazy way of writing percentage. Percentage. And then we have, well, we're figuring out how many wants our units are. Okay. Well, didn't look like a table yet, but now it does. Look at that. I just kind of draw some lines. So I'm going to take some data off of the table. On Friday, I have 43%. Saturday, I have 32%. Sunday, I have 17.5%. And Monday, I have 7.5%. For the wants, we have a total of 475. Now, we are going to be finding these wants based on, we're rounding to the nearest number, right? So there might be a rounding error. We'll see what happens. If there is, we'll deal with it. So 475. So for Friday, we have 43%. Now, just to make our lives a little bit easier for later, just in case there's an issue with our rounding, what I'm going to do is I'm going to write, oh yeah, I punched it in my calculator, I got 204.25, and I'm going to round that to 204. So I'm going to kind of make this column a little longer, so I have a rough estimate, and then we're breaking it down a little bit. So we see our decimal and it's rounding. Okay, so then I need to know what 32% of 475 is. So I do 0.32 times 475, like so, and I get 152. Yeah, just 152. It goes in perfectly. That's great. Cool. So we're not going to have any rounding errors on that one. Sunday, we have 17.5%. So if I convert that to a decimal, it'd be 0.175. Multiply that by the 475, and I get 83.125. So let's round that to 83. And on Monday, we get 7.5%. So that would be 0.075 times 475. And we get 35.625. Now, if I'm rounding that one would actually round up, right? Now, the reason that I'm trying to be careful is sometimes I'll end up with a rounding error and I'll end up with, say, 476 or 474. So what I like to do is I like to do this, and then I like to add them all up to make sure that my numbers work out. Just to make sure I'm not making a horrible mistake. So I'm going to add 204, 152, 83, and 36. And I get 475. Okay, so no big rounding errors, no big problems, because each of these had a little piece. These guys had little pieces. This one had one big piece. So that these two rounded down, that one rounded up. That's where that extra little rounding error could have been. So we're good. We got these numbers, all right? Now, again, our number one said how many wants did we have on Friday? Well, that was easy. 204, right? Number two said, well, how many less did we have on Monday since Friday? So one was Friday, and that was 204. Number two wants us to compare Friday to Monday. So we could do Friday minus Monday to figure out our difference. So 204 minus 36. It's 168. Cool. And then number three asks us, what percentage loss has there been between Friday and Sunday? Okay, so in that case, we're going from Friday to Sunday, so 204 to 83, and we want the percentage loss, the percentage decrease. So we need to know the percent decrease. Now, yes, I've been doing those and I've been giving myself a whole lot of space to figure those out. But I totally didn't give myself much space here, did I? That's okay. We're going to be able to do this real quick by figuring out our difference. 204 minus 83, we get 121. And then we take that, that's the difference amount, and we're going to divide that by our original amount to get our percent decrease. So in this case, I get 0.593137, blah, 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 blah. I'm going to just round it to the nearest tenth. So when I move this guy over, it's going to be 59.3. So 59.3%. So in that particular, see, I like being able to do it. Sometimes I kind of cram them, and that makes me a little punched for time. But I like being able to do that because you can see the difference for that problem we did with the puzzle pieces. For a problem we did with the puzzle pieces, we had plenty of room. We figured out our decrease amount, we labeled it nicely, we did the math, we wrote it out as a decimal, we punched it in as a percentage, we rounded it nicely. Look how much room we had. And then I crammed this one down here. So how much room do you actually need to figure these out? Figure out the difference, divide it by the original, convert it to a percentage, and there you go. That's how much room you really do need for these problems. So it's not too bad, right? So that's the circle graph stuff. That's nice. That, you know, we got our rough, we got our information from the circle graph. We made a table, and we used that table to inform us for our answers. See, we came full circle in 2 slides. Circle graph, full circle, get it? I'm giving everybody a minute to write it. Yeah, that's right. Someday I'll have kids, and I will buy books of dad jokes and memorize them.
I'll buy you the calendar.
Huh?
I'll buy you the calendar.
Oh, that's a good one.
I have one.
Yeah, you got to count. Desk calendars.
Dad jokes.
Oh, that's beautiful. They got to be the type of jokes to just make everybody sad.
I'll
Like,
give you an example.
Huh?
I'll give you an example.
Okay, okay.
Let's say. Today's was how do you make a squirrel your friend act like a nut?
Oh my God. Oh yeah, that does it. That is an awful joke. I appreciate it. How do you make a squirrel your friend act like a nut? Ah. Funny enough, I got some big trees in my backyard. Never seen a squirrel, found plenty of peanuts.
Not a squirrel.
I know they're out there. When the leaves fall and I'm far too lazy to rake, we end up, when I mow the lawn, I find that I'm chopping up all tons of nuts and peanuts and everything. Oh, it's bad. All right. Do we have the whole thing written down? You good?
Yeah. Well,
Yeah, you good? Cool. All right. Okay. Only got so much time left. I think we'll be able to glance at some of these, but not all of them. All right. So this one was new to me. I haven't actually seen this. It's incredibly similar to a bar graph. In fact, as far as I can tell, it's literally just you guys making a simple bar graph yourselves. That's really all it is. It's called a line plot. I don't know if I'm crazy or not. I just haven't seen one of these guys. So they're actually used to show frequencies or how many of something there is. They're a great way to organize information and they're pretty easy to read. They're usually represented by different sets of data underneath a line, and then X's for tally marks above that line to show each data point's frequency. I was looking into these last night. I also found several examples of these where people just drew dots. Some of them had different colored dots. I have no idea why. But the basic idea is if you look at this particular example, in this example, there's numbers at the bottom that says cookies eaten at a party, and it's between 0 and 6. So I would assume that each of those X's is a person. So there's an X over 0, so one person didn't. Over 1, a couple of people did. Over 2, there's 6. So 6 people had 2 cookies. 7 over 3, 2 over 4, 3 over 5, 1 over 6. So it gives you all of your data points that are on the bottom, and then you can kind of see how much of your information is there. So it's very similar to a bar graph, but you just literally just have those numbers there, and it's not bad. Now, speaking of bad, I decided to make a line plot example. So this one, we're going to have to be a little delicate on how we're going to do this. So we're going to create a line plot with the following list of student typing speeds in words per minute. I'm going to end up, let's see, so we have the smallest number in here is a 38, nope, 37. So I'm just gonna make a little list of all of my possible data points. The biggest number we see is 44. Okay. So what I'm going to do.
Yeah, well, there's 44.
Yeah. So I see a bunch of 44s. I don't see anything higher than that. So we're going to do this. Let's see. So I should be able to select both of those windows. I'm going to set it up so everybody online can see what I'm seeing I don't know if we'll see it in the same way I'm seeing things. Don't want it to look awful. It's probably going to look awful. So don't know if people see things the same way I do, but I basically made a line, and then I put all my possible data points right under those lines. And this is going to be our words per minute or WPM, whatever you want to do. And I'm going to look at my chart essentially of different data points. I'm going to start from the bottom left or top left. I'm going to read across and then go down a row and then go down a row and then go down a row. So starting from the very top, we have a 39. So we're going to put an X on the 39. We have a 43, 41, 42, 40, 37, 38, 42, 37, 41, 40, 39, 44, 43, 42, 42, 43, 43, 38, 43, 44, 42, 44, 40, 44, 41, 40, and 40. Whew. Hideous. All right. So we have our line plot. So let's look at the question surrounding it. So for number one, what are the most common? Now, I don't exactly have the straightest lines. If you made this nicely, the reasonable way would have been probably to having an X in each line separately. I absolutely didn't do that. So there seems to be 5 under 40, 5 under 42, and 5 under 43. So those would all be tied for the most common words per minute. So 40, 42, and 43 words per minute. 2, what percentage of students type at 39? Well, heck, I don't know. How many data points did I have? So if I want a percentage, let's see, I had 1, 2, 3, 4, 5, 6, 7 columns and 4 rows. So I had a grand total of 28 data points. And at 39, we had 2 at 39. So if we want to know what the percentage did this at 39, well, part over the whole, right? We had 2 of them out of the 28 of them. Punch it in Mr. Calculator. Hi, Mr. Calculator. 2 divided by 28. We get 0.7149, blah, 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 blah. So let's say it's 7.1%. 7.1%. Okay. And then how many of the students type at more than, greater than 40 words per minute? Well, that's not asking for a percentage or anything. So all we really need to do is just add up all these data points. So let's see, there's 3, there's 5, there's 5, there's 4. 5 and 5 gives us 10 plus another 3 and 4. So that's 17. All right. So you can tell that, I mean, would you want to answer these questions based on that weird grid of numbers, or would you want to answer these questions based on the table we made? Table, right? It made our lives easier, even though it took a while to set up. Not my favorite thing to do, but it worked out. So I see the benefit of making a line graph. And I realized that I haven't used this specific format before, but I've definitely made something like this before. You know, if you have to figure out a frequency of something, you'll write it down and you'll start making tally marks, right? I mean, it makes sense to me. I don't know. If I was doing this without knowing about a specific name for a line graph, I probably would have made a table that looks like this, and you guys don't need to write it down. I'm just doing this as an example of something I would have done, and probably you guys would have done. And I probably would have started making tally marks and saying, oh yeah, there's 2 of those, 2 of those, 2 of those, 5 of these, 3 of these, 5 of these, 5 of these, and 4 of those. It's the same thing. Most people have done this at some point or another. So this would just be the more stringent mathematical graphing way to do it. So now if you see something like this on a test, if you get asked to make a line plot, you've seen it. You've seen it now. And you could say, oh yeah, they want it to look like that, but it's totally these. Because yeah, you've seen these. I've seen these. I've made them at work. It drives me nuts. Okay. Let's see, what do I? Yeah, I can't cram that in 5 minutes. Okay. So how do we feel of the stuff that we have learned tonight? Are we okay? Are we scared? Are we crying?
Oh, scared, of course.
Yeah. I feel like you don't have that much to be afraid of. I think you're good. I think you're good. All right, guys, so we are totally done. I am done, you are done. If I'm done, you're definitely done. So I'm calling it quits for the night. We will pick up again on Thursday. We're going to look at some more of these. Oh God, I just realized that for my review, I have to make more examples. And then we will look over the rest of the types of graphs and linear equations. We were going to start doing linear equations, and as a hint, we have totally done linear equations already. We have totally done that already, just a little bit, but now we're putting names on things. All right, everybody, have a good night.
Bye, man. See you Thursday.
See you then.